Shh. Let's have a look at our learning intention today. So we're looking at composite shapes today. We're still learning about right angle triangles and apply the Pythagoras Theorem. We did say that when it's a hypotenuse, it would be a plus. When it's a shorter side, then it would be a minus. So let's probably start with a warm up. Have you heard of the term Pythagorean triple? Anyone? Pythagoras triples. And how would we be able to use the Pythagorean triples? Now, those are some of the Pythagorean triples. There's heaps of them. Some would call it as Pythagorean triads. So you've got 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. What do you notice? There are multiples of the top. That's right. Who saw that? So you've got 3, 4, 5. Underneath it would be 6, 8, 10. Underneath it would be 9, 12, 15. So if you multiply each of the sides of a 3, 4, 5 triangle by 2, you get 6, 8, 10. If you multiply each of the sides by 3, you get 9, 12, 15. If you multiply each side by 10, then it's 30, 40, 50. Or that if x represents any number that you multiply each of the sides of the 3, 4, 5 triangle, then you'll just have 3x, 4x, 5x. Yeah? The same thing with the second column. You've got there 5, 12, 13. If you multiply each of the sides by 2, you get 10, 24, 26. Then next 15, 36, 39. So what would be the application of this and how would this be useful? And I know some, you don't have to memorize all of them, but you just need to know some of them. Let's say this was 6, this was 8. Then because I know 3, 4, 5 triangle is a right angle triangle, and I see that's 6, that's 8, without any further calculations, I know that this must be 10, because that's from the sides of a triangle wherein that's 3 times 2 and that's 4 times 2. Therefore, that must be 5 times 2 as well. Let's say, for example, this was 80. And I know this is 170. Then this is the one that's missing. Well, I know such a thing as an 8, 15, 17 triangle, right? And I know it's a right angle triangle because it's one of the Pythagorean triads that I know. And therefore, I see that that would be simply 8 times 10, right? That's 17 times 10. So this must be 15 times 10. And therefore, I'd say that this must be 150. And that's my answer without actually using your Pythagoras theorem. So if this was missing as x, then we say x squared equals 170 squared minus 80 squared, right? Now I would have to use my calculator. 170 squared, I get 28,900 minus 80 squared, I get 6,400. I minus them. And I get 22,500 and end up with the square root of that, which is 150. And lo and behold, that's the same as what I got here without even calculating, only because I know these Pythagorean triads. So let's have a look at our lesson for today. It's entitled as Composite Shapes. Who can tell me what composite shapes are? Anyone? You can tell what composite shapes are. All right, composite shapes would be shapes that would be composed of, right? Composed of different shapes, right? So when we learned about Pythagoras theorem, they would only work with triangles, right? And sometimes when we talk about perimeter, right, there would be some missing sides. Now, some of it you would be able to figure out the missing sides using your Pythagoras theorem, just like the first example that we've got there. So it says there, find the length of the side x, give your answer correct to 2 decimal places. So this figure here, who can identify for me, or who can name that that shape for me, that quadrilateral? So it's got 4 sides. What's the name of that quadrilateral? We'll give you a clue. It starts with a T. Trapezium. Thank you. So it's called a trapezium, right? So that's a trapezium. We know it's a trapezium because you've got 2 opposite sides which are parallel to each other, right? I know they are parallel because you've got there your square, or that saying they are perpendicular. It forms a 90, and therefore these 2 are parallel, right? So what we're given is that this is 8 centimeters, this is 4 centimeters, and this is 10 centimeters, yeah? So what we want to find out is the length of this diagonal, right? But we said the Pythagoras theorem only works for right angle triangle. This is not even a triangle. So how can we use this then? Because they are called composite shapes, we can cut that shape into several shapes. We cut it into a triangle, specifically not just any triangle, but because we're talking about Pythagoras' theorem, then we want to have a right angle triangle. It looks like it's the hypotenuse because it's the side that's opposite your right angle. Can you tell me the lengths of those sides? So the known sides are 2 and 4. Which one is 2? The horizontal, well, this one's 4, right? And it forms a rectangle, and therefore if that's 4, we know this is 4, right? The horizontal is 2, that's right, because that's 8 there, and the whole thing is 10, yeah? So the difference must be that this is 2, yeah? So now we've got this right angle triangle wherein the legs would be 2 and 4. He got 4 and 16. That becomes 20. And for us to get x, we get the square root of 20, right? And again, this is in exact form, or what we call surd form, right? That can also be simplified. We'll just learn that in year 9 next year. Okay, something for you to look forward to. So the square root of 20, we get 4.47. And that's to 2 decimal places. So the way we'll be able to do it is if we look at the inside triangle, we would actually have a triangle wherein you've got 2 sides that are known, which would be 6 as our hypotenuse because that's opposite the right angle, and this as 2, right? And this is our missing side, which is x, yeah? So now we've got one of the shorter sides unknown. Let's use our Pythagoras theorem. X squared equals 6 squared. What do I need to remember for my formula for this one? I minus, thank you. So I've got 6 squared minus 2 squared, and that's 36 minus 4. I get 32. And for me to get x, I get the square root of 32. Again, that's in third form, but you can use your calculator to figure out what the square root of 32 is. Did it say to 2 decimal places? So we've got 5.66. So are we done here? No, we're not. We're done with figuring out what x is, which is 5.66. Yeah, but we still need to figure out what y is, yeah? But then now we know x, we know the hypotenuse here, yeah? This hypotenuse here, let me use green, that one, and we know this side as well, yeah? So now we would be able to figure out what y is. Yeah, again, that would be one of the shorter sides. And therefore we say y squared equals, this time our hypotenuse would be 15. 15 squared minus 5.66 squared, or you can use your answer squared, or even you can use square root of 32 squared. Yeah. And therefore you have what's 15 squared, that's 225, that's 32, and 225 minus 32 would give you 193. Y therefore is square root of 193, which is 13.89. Okay, so you're free to go and you're free to start with the work today. All right. Good morning, and I'll see you next week. Bye.
Come on, Rocky, let's go.